Thank you for the nice introduction. Thank you for allowing me to be here and present my work. Being an architect and not a sociologist or economist, I will not talk about the future of work in general terms, but from a very specific angle perspective, that is that of architecture. My talk will be about the impact that digitalization at large and in particular digital fabrication technologies have or are actually having on the design as well as on the production of architecture. My hypothesis is that architects as cultural actors will have to directly and deeply engage in a real dialogue with machines. Such an engagement will not only avoid being ruled out by the upcoming structural change as architects, but this is very important to understand our own motivation to engage with machine. It will extend our reach into the domain of construction and finally allow us to design things that we could not design in another way without machines. I will present in this talk the research our architectural firm is doing both at ETH in Zurich as well as at the Future City Laboratory in Singapore of ETH. So now before entering and presenting the serious academic research, I would like to show you a very old project of us in which we playfully engaged with technology by employing a mobile phone almost 10 years ago. You will recognize this mobile phone by designing an interface to produce a table through a mobile phone. As you can see in this movie, the user distributes a number of pressure points directly by pressing the joystick with his thumb. And by doing so, he deforms the lower surface of a table until it intersects the planar upper one, creating a hole. Then he chooses material, a color, dimension, usual stuff, and uploads the file. By doing so, he produces digital data. Here you can see the parameter of the just designed table, a very minimal set of information that is almost human readable. You will recognize an author, you will recognize a color, and this minimal data is sent to our server from the mobile phone. By knowing the design rules on our side, so by knowing the rules of the game, with this little amount of information we can rebuild such a complex doubly curved surface that in the further step can be, if appropriately formatted, sent directly to a machine, in this case to a CNC router that produces the table out of real material. As you can see in this process, we directly move from data to material, from the digital to the physical, from the low resolution of this very old mobile phone to the highest possible definition, that is the definition of material, without any intermediary steps. Although now in 2014, in the age of pervasive mobile computing, of app stores and so on, this project might look technologically outdated, and the proposed design, a table with hole, is clearly a problematic thing. This project has a playful, ironic undertone, even more if the design is not done by a professional designer. This project still very explicitly illustrates this seminal paradigm change, which is introduced by digital fabrication technologies. Besides challenging the established relationship between the designer, the producer, and the user of architecture, it becomes apparent, and this was clear in this last image, that digital fabrication has this potential to create a differentiation, variation at no cost at all. Now, paradoxically, you should sync the images, please. Paradoxically, with pervasive digitalization of everything, of society, in architecture, the reverse, the materialization of the digital becomes the focal point. we're witnessing a sort of second digital age in architecture, which finds its contemporary expression in this interconnection between data and material, between digital design and digital fabrication. In order to investigate this phenomenon in an empirical and materialistic way, in 2005, so 8 years ago, we set up at ETH Zurich a laboratory for the investigation of the phenomenon we call digital materiality. And at the core of this laboratory, we placed a machine, a very specific machine, that is the industrial robot that you see in this image. The industrial robot is a versatile, robust, affordable machine that has changed the logic of industrial production, if you think of automotive construction, in the course of the last 30 years. But the most important feature of the robot, making it interesting for architecture, is to be found in its genericness. Now, as this image shows here, the last image was kind of a very objective image showing the machine, showing the setup. This is a subjective image done by an artist. It shows that we are not interested in the machine per se, in the machine alone. We are interested in the relationship between the machine and us as human. And it's astonishing that most current debates about automation and so on, about the relationship between human beings and machine, voice almost exclusively a kind of a critique whose content can be traced back to the early days of industrial automation in the last century. These reservations, of course, pertain to the potential destruction of jobs, of craft tradition, even of social values. Now, although we recognize the risk of this structural change, we are convinced that, or let's say we do not believe in this dichotomy, and are convinced that we should, between humans and machine, in this contrast, in this opposition, and we think that we should rather think in terms of complementarity, in which humans and machines are equivalent partner in a sort of collaborative process. In fact, the machine needs the human as much as the human needs the machine. In this process, the human designs the rules. In this case, the rules of brick bonds, and formalizes those rules in a computer program, in this case. And the next step of the chain, these algorithmic rules, if appropriately formatted, can be translated into spatial movement performed by a machine, in this case, an industrial robot. And thus it becomes possible to directly connect the human act of design, depicted on the left, with the robotic machining act of construction performed by the machine. And as you can see in this image, depicting an early prototype of such a robotic brick wall, the result of this simple direct connection between data and material is astonishing and very clearly illustrates the emergence of a phenomenon we call digital materiality. With its ability to position each brick in a different position, in a different way, the robot creates a complexity that lies far beyond what could be done by a human actor, by a mason in this case. Now, in order to illustrate the potential, the architectural potential of robotic bricklaying at a larger scale, I would like to quickly show two build examples. The facades of the Gantenbein vineyard were prefabricated robotically, as you see in this movie, in a sort of 3D printing process, whereby the robot not only places each single brick in its individual position, but also applies the adhesive, the glue, as you see in the movie. This is crucial, those two steps are crucial, because all the overlappings are different. After transportation to the building site, those prefabricated elements are placed on site with a crane in a very traditional way. Now, depending on the position of the sun, as well as on the position of the viewer, the relationship between those two positions, the plasticity and hue of the facade changes dramatically, as this image shows, while from close up, the three-dimensional appearance that you have from far away dissolves in the materiality of the stonework. From the inside, the opposite occurs. at the phenomenological level. Here the effect is not generated by the surfaces of the bricks, but by the variation of the gaps given by the rotation, which in turn creates this distinctive modulation of the incoming light. The second project, Structural Oscillation, is an installation conceived for the 11th Architectural Biennale, where the robot was transported to Venice in a freight container, where he produced the needed wall element for installation directly on the building site in front of the Swiss pavilion. The resulting wall loop in installation adapted its shape according to its course, widening, narrowing, producing tension-rich spaces, leading the visitors through the exhibition. And through the rotation of the brick, which increases the highly articulated of the wall, this wall gets an almost textile character that stands in contrast with the firm, heavy materiality of the brick. At this point, I would like to make a scale jump and show you a couple of impressions of a design research studio we are teaching at the Future City Laboratory with architecture students in Singapore, where we investigate how computer programming and robotic fabrication can be used in design both as a conceptual and methodological level. Here in this studio, with 1 to 50 study model of high-rise structures, we basically simulate the new working condition and the new working environment of the architect, which engages directly with robotic fabrication processes. While becoming part of the design process, these machining procedures designed by the architect function as a catalyst for novel design methods. In this experimental approach, the students developed, as you can see in these images, a spectrum of custom robotic tools and procedures for the build-up of their model. This image shows a custom-developed process that allows the student to bend acrylic parts to a specific angle, which is needed for their designs. Now, the resulting study models that you see in these images embody the knowledge of their own incremental build-up logic. So this tight link between the design and the fabrication logic is given at every moment during the process, and they are thereby insistently real experiments that materially condition the digital design and bring it to expression. Through such hybrid digital-physical methods, the physical study model, that has a long tradition in architectural design and history, gains again a central significance, but this time in the context of computational, of digital design. Now you would ask, why is the development or the investigation of such a new design culture important at all? If we look at many booming cities around the world, in emerging countries, in Asia, Southeast Asia, like here in Singapore, a city-state depicted in this image, which develop towards sort of hyperdense vertical urbanism, we will notice that despite, here again, this is Singapore, the central business district, despite this very iconic downtown areas, which are kind of addition of star architecture, we'll also notice that the large majority of standard developments still look like this. This is also Singapore, just a couple of miles away from downtown area. These developments are dominated by the paradigms of prefabrication, of standardization, and of industrial serialization. And they are deeply rooted in the 20th century and its logic of economies of scale. With our research, in contrast, we want to, and with machines, we want to introduce more freedom, more flexibility, and more complexity into those standard development. And in fact, we believe that with robotic automation, it will be possible to reduce the cost of form and to attune the construction logic of those buildings here to the logic of the 21st century, so to the logic of the information age. Now, how do you want to achieve this? Of course, we want to achieve this through automation, through machines. But the automation we envision radically differs from previous approaches. And this image shows systems for the automatic construction of high-risers that were implemented mainly in Japan and South Korea in the 1990s. And they largely failed for mainly for two reasons, because first they were too expensive, and most important, they were not flexible enough to accommodate the diversity of architecture, that it's a contextual cultural discipline. These were like this example by Shimizu Corporation on the slide, literally vertically moving factories, aiming at the complete substitution of human labor, at the complete automation of the construction process, where human labor factor was conceived in tune with the logic of automation in the 20th century as a mere disturbing factor, as a risk, introducing inefficiency, additional costs, and so on. So I think that you would like to eliminate. In contrast, we believe that by employing small, flexible, and generic machines like industrial robots, here you see a prototype mounted on Caterpillar tracks, and by equipping those machines with powerful and precise sensor system that allow them to locate themselves in the environment, and, very important, to collaborate, to interact with humans. This image shows an experiment where researcher shows the machine where to build something without entering any code, just by gesture. We believe that we can conceive adaptive construction systems which rely on both feedback systems as well as on human interaction, but now on human interaction at the level of real collaboration. With such systems, at the end of the day, we believe, and paradigms, we believe that we will be able to update the logic of construction from the paradigm of repetition, depicted on the left, towards more differentiation, and finally succeed in this century-old project of the automation of the building industry, but from a different perspective. In order to achieve this, we will not only to develop better and more intelligent machines, but also suitable construction processes. Now, as opposed to the bricklaying thing that I've shown in the beginning, that are able or allow us to fully exploit the specific strength and potential of the machine. Mesh mold, the research project we are investigating in Singapore at Future City Lab, is part of this effort. Now, if you want to produce reinforced concrete, which is a wonderful plastic material that can take on any form, that can be optimized, you basically need two things. You need, of course, the concrete, but you need a formwork and reinforcement. Now, those two things are very, very expensive because they're very labor intense and need a lot of material. In the mesh mold project, what we try to do is to fold the reinforcement and the formwork into one single robotic fabrication process. I will show you how we envision to do this. As you can see in the movie, the robot extrudes material freely in space. It's kind of 3D printing. This is the strength of the machine. This is a thing the human cannot do. And this liberty afforded by the spatial extrusion, as opposed to layered deposition of conventional 3D printing processes, enables the resulting structure to conform to its structural requirement by adapting, for example, the density of it or geometry itself. And although this robotically fabricated mesh structure that you see here is extremely light, it is also astonishingly stable and can be used as a leaking formwork for free-form concrete construction, where concrete is poured into the mesh formwork and protrudes through these open mesh structures, covering the whole structure in the end and being thrown away. The direct extrusion of formwork in situ, meaning on the building site, so trying to surpass this paradigm of prefabrication, allows for a greater geometric complexing while at the same time simplifying the project process itself. And since the global amount of material is reduced to a minimum, such an approach holds a potential for both resource efficiency and sustainability. Now, although these projects are still at the stage of fundamental research, we firmly believe that they will play a role in construction industry in the next few years. As a contrast now, to conclude to this project, I would like to show an installation we did together with our friend and colleague, or ETH colleague, Professor Raffaello D'Andrea, where several flying robots assembled over 1,500 elements to create a porous tower-like aggregation. Here, what unfolds as a 1:100 scale model of an architectural vision for a 600-meter high vertical village, providing living space for about 30,000 inhabitants. In a playful way, as you see in this movie, flight assembled architecture introduces a radical expanded scope of digital fabrication. Hereby, the quadcopters are not only used as an enabling technology, but also as a sort of conceptual door opener in order to make radical architectural utopia possible. At a scale 100 times smaller than the vision, the installation calls into question the supposedly clear line between reality and utopia. After this project that is clearly projected in the future, it is intended to be an art installation. I would like to summarize the most important aspects of my presentation. First, in order to avoid repeating errors and failures of the past, we shall use generic and flexible, robust machines that right now are kind of embodied by industrial robots. This can change in the future, which are equipped with sensors that allow feedback systems and, in the end, interaction with humans. And this is the second point that is crucial to our thinking. We think that we should rethink the traditional competitive dichotomy between human and machines. And instead, we shall capitalize on both the strengths of human and machines and understand this pair as being complementary and synergetic. Third, with digital fabrication, we can rethink construction logics, making complex pre-industrial constructive solutions which have been ruled out by the laws of rationalization and standardization possible again. And as well as this mesh mold technology has shown, we can invent new processes that are attuned with the specific strength of robotic fabrication. Fourth, we're convinced that in the future, the focus will be set on the design of processes rather than on the design of forms. And these processes can lead, as the first project, this playful table project has shown, to very strong formal outcomes, which nevertheless stay open for variation and allow interaction with humans, both at the level of design as well as at the level of its fabrication. Now, last but not least, digital fabrication fosters, despite its digital derivation, its implicit rationality, a strong and unexpected material sensuality. And for this reason, we shall not conceptualize technology only from a functional perspective, but focus on the aspect which can produce an architectural added value. In other words, it is our mission as architects to engage with technology at the cultural level. As technological innovation happens anyways, independently from our own contribution as architects, if we fail engaging, we miss a chance to shape the future of our profession, and thus the future of architecture, and we'll end up being obliged to use systems which do not correspond to our value system and do not incorporate the human factor as much as we would like. Thank you very much.
That's awesome stuff, Fabio. Let's see. Okay. So the audience, you've been talking about the architect, right, and the architecture, but the audience, what I see from Twitter, they've been thinking about construction workers. What do you have against construction workers?
It's not a matter of construction workers. I think the structural change will happen, and we should not think, well, we live in a global world. This global thinking most of the time is problematic, because if you look at the singular economies, at single countries, you will find that the reality behind construction logics is completely different, because it has a tradition, it has certain needs, it has the reservoir of labor or doesn't have it, it has labor, skilled labor, it has artisans, or just has, and this completely differs. So I think we should precisely look at what is needed by the specific economy, and then propose systems that allow to integrate with those workers. Of course, on the mid-long term, the unqualified jobs, the dangerous jobs, will be substituted, and this is a trend we have seen in last century throughout many industry, being substituted by machine, and there we are firmly convinced those people, maybe not the same structural change, is problematic things and would create victims, but the people engaged now in less skilled works will control those machines.
Right.
Maybe this doesn't make sense for economics like China now, that has a reservoir of unskilled labor.
Sure, but look at Switzerland.
But in Switzerland, in Japan, I mean, those experiments we have seen from Japan, the driver behind this was the booming economies in the 80s. They didn't have anybody wanting to do anything on a construction site, and they didn't have the political means to import cheap, unskilled labor force. So they had to think of technology to solve the problem. They just did it the wrong way.
Yeah, and I totally understand how you're saying that architects need to engage with these developments and not wait for engineers from like other industries like innovate in this space, and then it comes to architecture, and then you guys have to adapt. But that's basically what happened in the past, right?
Yeah, I mean, this already happened with software. We are the victims of our failure to participate in the development of computer-aided design software. While other industries, film, movie industry, for example, did this proactively. So the choice now is less on is it good or is it bad, but is can we shape it in a better way that will be more human, be more interesting, and produces an architectural added value, or to refuse to be part of this development, you end up being obliged and being the victim of a development that happens anyways. So we choose for the first solution, also because it's interesting to do such stuff.
And they congratulate you on that. Thank you very much, Fabio.
Thank you.